Hey everyone, this is FixReef, and today we have another Kessil A360X in for repair. This one came in with a problem that it's not turning on at all. In my previous videos I had a problem where it would flash, it would turn on and off periodically, but this came in with an issue that it's not turning on at all. So I have no idea what's inside, I don't know what the problem is. Let's open it up and find out. Because this light is not water damaged, I'm going to plug it in and find out if indeed it does not turn on at all. Let's do this. Let's connect my lab power supply and we'll use it to see if it's drawing any kind of current on power on at all. The lab power supply is on. You can see there is absolutely no sign of life. I am not seeing absolutely nothing drawn from the power supply. Typically I would expect maybe 10 milliamp or so used by the controllers even when the light is completely off. But in this particular case there is absolutely no sign of life. I'm changing the dials here, changing the intensity and the color, and nothing at all is happening. So it is clear to me that at this point it's not consuming any power whatsoever, and there is likely an issue with the light itself. So let's take it apart. I can see that there is a little bit of salt creep around this. Hopefully it's clean on the inside. The fan is mostly clean. The board is of course covered in coating. So also fairly clean. Let's take it completely out. Okay, so this is the power circuit. It's right here. If you have not seen my previous video on repair of this type of light, go ahead and I will include the link in the description. Go ahead and take a look at what's going on there. But this is the main power circuit. You can see that the power comes in here, right by USB ports. It comes out over on this end and kind of travels from out here all the way through and around and goes out this way. So this whole thing over here is the main power circuit. When the power draw on the lab power supply is at complete zero, it means that something over here is damaged. We have a power MOSFET, we have the power control circuit breaker, so to speak, a couple of diodes, a diode, a couple of capacitors, current sensing resistor, and some additional configuration and auxiliary components. First of all, I have not seen this light fail in such a way that it wouldn't be any power draw at all. Usually it flickers, and the reason it would flicker is because there is an issue with the circuit breaker and the MOSFET. It's still entirely possible that the MOSFET is bad, but I am curious if anything in here is causing trouble as well. Let's turn it around so that you can see. And I'm going to test a few basic components of the circuit. Okay, let's test this. All right, let's start with these capacitors. And the diode. This should conduct. Yes, it does. Now let's see if the MOSFET is having problems. Not so much. Okay, to make my life easier, I am going to remove conformal coating around this area. At the very least, the circuit breaker and the MOSFET. So I rigged this up so that I can find out what's going on when the power is applied. The problem is clearly with the circuit on the power end. and something's not getting this MOSFET on at all. So what I did here is I'm just going to measure two channels. I'm going to measure the gate at the MOSFET, and I'm also going to measure the timer. So let's switch over to the schematics so we can understand what's happening there. So this is the schematics for the power controller. You can see that it's controlling the gate of the MOSFET, and there is a timer as well that's fairly critical. If you look through the data sheet, you'll realize that the timer is playing a critical role in every single operation of this controller. Let me go down. Here is an example of the power up sequence. There is the timer pin right over here. When the power comes into the controller, at some point the timer starts ticking because the whole unit is off. It reaches the value, and that kicks off the power gate. As the timer is charging because it's unhappy, because the output is not where it's supposed to be. At some point, the controller is going to turn on the gate, and when the gate is turned on and the output voltage starts flowing, that's when the timer is happy. So you can see that it charges to about 4 volts, the gate is on. There is some fluctuation going on, initial startup, it's moving it out, and as long as there is an output voltage at the gate and everything's good with the current, the timer is discharging and it's happy again. So this is what we are supposed to see if we were to capture the waveforms. Let's see what we get to see in reality. So I'm going to start capturing. Let's turn on the light and turn it off again. And let's stop. So this is what we get to see on the waveform. The yellow line would be the gate, and the blue line would be the timer. Let me see if I can zoom in a little bit. Okay, so the timer drops, previously charging, the timer drops. As it should, starts charging, and then drops again. The gate never comes on. In fact, the gate power drops as well as the timer. Let's now take a look at what failure scenarios we get to observe in the datasheet for this. Many of the most common issues are described in the waveforms below. Once again, this is the startup sequence. The timer is this line over here in red, and the gate is this pink line up at the top. In our case, the gate never rises, and the timer is not quite functioning. It's definitely not startup into short circuit, because there is never a spike on voltage in or at the gate. It's not an under voltage case, it's not an over voltage case, because I already know that I'm providing proper voltage. It also doesn't look like it's a hot circuit. Once again, the gate does drop, but the timer is gradual increase, not what we've been seeing. See, the short circuit zoomed in over here is not what we get to see. None of these failure cases, none of these failure modes are actually is what we observe. We just see that the timer charges and then drops down just like it would in the startup circuit sequence. So I think it's kind of working, but the gate is going down sharply. What this suggests to me is the gate is potentially shorted to ground when the power is applied. So it's attempting to turn it on, but the gate is shorted to ground. My hope is that the problem is with the power MOSFET. So we're going to go ahead and attempt to remove the MOSFET and replace it and see if we get the proper contact. Let's add some flux. Not that it's going to help at this level, but just because. And now let's see if we can get it off. I think it's coming off. And it's off. Alright, now is a good time to remove all of the old solder. This looks good. A bit of cleanup. This looks nice and clean. Now let's replace old solder with fresh leaded solder. This should be good enough. Of course, we'll need a lot of flux on here because the MOSFET is new and it's dry. Alright, let's install and see what happens. Now it should be much easier because we have leaded solder in there. Okay, we squeezed out some balls. We'll need to remove that. Okay, and the brand new MOSFET is in place. Needs good cleanup at this point. Lots of mess with the flux. Look at this. This looks really good. I think the MOSFET is fully in place. Let's get out of the microscope and test. Okay, are we going to get the fan spin at this point? Or is it going to be smoke? Let's find out. Nope. It was clearly not a MOSFET. Okay, so after replacing the MOSFET, the light still did not work. So I had to, off camera, do some more troubleshooting, and I think I found the problem. So let me zoom in a little bit and I will explain what I did. All right, so hopefully you can see this. So first off, I've removed these 0 ohm resistors. These resistors are essentially conducting the power from the MOSFET over to the main line. By removing these MOSFETs, I made sure that the shutdown is not causing by a short. So this essentially cuts off power to the rest of the light, but I would expect to still see 19 volts coming out of the MOSFET. That did not help. Then I started looking into this mess. You can see how I cut out a lot of compound here and exposed a collection of these resistors. Unfortunately, let me see if I can actually bring it closer so you can see a little bit better. So over here, we have 4 resistors. There are 2 resistors here and 2 resistors here. These resistors act as voltage dividers, and they tell the main controller to shut off if there is an overvoltage event, too much voltage being applied, or under voltage event, too little voltage is applied. If any one of these resistors is messed up, there is a wrong voltage being sent to the controller, and it does not know that it's supposed to turn on, or for that matter, it thinks that it should turn off. And this is exactly what happened. I removed all 4 resistors, and of the 4 resistors, 3 had bad values. They were not shorted, they were not didn't fail open, they just had wrong values to them. So after replacing 3 of the 4 resistors on here, I think I got the light fixed. Let me again demonstrate this in the datasheet. Okay, so this is the schematics. You can see that this resistor R1 and R2 and then R3 and R4 are the resistors that are voltage divider resistors. R1 and R2 enable the chip and also act as an undervoltage protection. R3 and R4 are supposed to be an overvoltage protection. So of these 3 resistors, I believe only R4 had the correct value to it. Everything else was either incorrect value or failed open or burned out. Replacing them, I think, fixed the light. Let's take a look. Now the light is connected to the lab power supply. I will give it some voltage and look at this. The light is on. Way too bright too. Hey, this light is fixed. Okay, well, let's finish it up. I'm going to apply a little bit of coating on the exposed area to make sure that it's protected from oxidation. This should be enough. We will let it dry, and in the meantime, again, let's recap what happened here. In my previous Kessil repair of this specific light, I had an issue with the main MOSFET. It burned out and I had to replace it, and it worked again. Here we replaced the MOSFET and it still did not help. Not a big deal. it turns out that the problem was not with any of these two components, but with the voltage dividing resistors that effectively enabled the main power controller to provide power and turn on the MOSFET. Once those resistors were removed, everything worked well. Bottom line is, it's not always the MOSFET or the controller that go bad, but apparently resistors. I do not often see resistors failing. That's the reason why I did not check it in the beginning. But in this particular case, 3 of them failed. 2 or 3, who knows? But either way, they're now fixed and the light is working again. Well, this completes this repair. If you enjoyed the video, please like and subscribe. This will motivate me to work on more videos. I'm here fixing all of these units. It takes time to figure them out. It takes time to understand what happened. It takes time to actually fix it. It also takes time to record these videos for you guys. It takes time to show in a way that it's meaningful what the problem is and how to fix it. So what I'm asking in return is to please like and subscribe so as to motivate me to keep recording this and posting them for you. And with this, I will see you next time.